So at Cummins, we are looking at hydrogen internal combustion engines as a step towards destination zero strategy. Hi, I'm Nilesh Deshpande. I lead the engineering function for engine business for Cummins in India. So hydrogen internal combustion engine works very similar to a diesel or a natural gas engine. Basically, you have hydrogen stored at very high pressures in cylinders that gets fed to an engine, and you combust or burn it in the engine, and the pressure on the pistons is actually what drives the engine. Very similar to any other engine that we use today, like diesel or natural gas. So there are three key differences between hydrogen ICE and fuel cell. Number one, how hydrogen is used. So in H2 ICE application, use hydrogen, produce mechanical power. So it's basically a chemical to a mechanical transformation. In fuel cells, you actually use the chemical energy to finally create electric power at the end of the day. Number two difference is in terms of integration. Because H2 ICE produces mechanical power, you can still use all the vehicle aggregates to drive your application. In case of hydrogen fuel cell, you need to integrate a battery and an electric motor for you to be able to use the power that fuel cell is producing. Finally, from a quality perspective, hydrogen ICE can actually use lower purity of hydrogen. The fuel cells actually require 99.9999% pure hydrogen for it to be efficient. So there are four key challenges for us to note. Number one, these hydrogen being the slightest element requires actually high pressure for it to be stored. So we have type 4 tanks which are typically designed for hydrogen applications which go up to 700 bar. These are actually carbon fiber composite tanks which are required to be mounted on the application for us to store hydrogen. Number two, since hydrogen is again light and much smaller molecule than natural gas, there is chances of it escaping from any gas. So sealing becomes quite an important criteria for us to know. Number three, hydrogen can actually penetrate material, causing hydrogen embrittlement. So this is an important phenomenon to consider while selecting the material that we use for storage of this application. Typically, we use stainless steel or anodized aluminum. And lastly, being a gaseous fuel, it is not great at lubricating any moving parts. So any interfaces that are moving require special consideration and special coatings as a part of this. At Cummins, we are championing and developing the entire hydrogen ecosystem, right from electrolyzers to tanks to actually hydrogen powered fuel cell and IC engine vehicles. Cummins is working across the hydrogen ecosystem, and we are very excited to showcase our cutting edge product at Bharat Mobility Expo 2025 from 17th to 22nd Jan. Do visit us to explore the future of sustainable transportation and see firsthand how hydrogen engines can revolutionize commercial vehicle fleets.